Welcome to myprojectbazaar.com. Let we discuss about the process image segmentation using rough fuzzy medoid algorithm. Let me see the abstract of the process image segmentation using rough fuzzy medoid algorithm. In this process, the color images were selected initially, the obtained color images were taken and they are initially pre-processed, that is the common resizing operation is employed. Then the color channels in the images were separated and the overall intensity of each channels were estimated. After that, fuzzy medoid segmentation is employed. The fuzzy medoid segmentation divides the images into different regions based on the intensity differences in the images. This intensity differences is identified with the help of the analysis of distance between the nearby pixels in the images. The obtained images were of representing similar intensities with similar colors. The input images were initially subjected to patch separation, that is, the images were divided into small regions, and for each regions the fuzzy medoid segmentation is employed. After the segmentation is employed to all the regions, they were combined to produce the final image. This image is then superimposed with the original images in order to produce the final segmented image. This segmentation process indicates different intensity regions in the images with exact different color representations. The performance of the process is measured in terms of PSNR and MSE of the process. Let us see the flow of the process. The input image is commonly taken. The color images were taken in this process. From the obtained color images, filtering operations were employed. In the basic filtering operations, the resizing operation is done to resize the images into a common size. After that, the color channels were extracted from the images. After the color channel separation, the red, green, blue intensities of each images were identified separately, and the overall intensities in each regions were identified. After the channel separation, the images will appear like the gray images, and in each images the channel informations and the intensity ranges were obtained. After that, the clustering processes were employed based on rough medoid segmentation. In this process, the similar intensity pixels were grouped in terms of the identification of the differences between the pixels. First, the images, the each color channels were separated into small patches. Here we have separated into 4 patches in rows and columns. Totally we have splitted the images into 16 patches. So in each patches, the medoid methodology is applied in order to obtain the overall intensity differences in the particular regions. The application of the intensity regions in each of the batches were finally combined in order to produce the final clustered images in the size of original image. After this, these images were superimposed to the original images. After clustering, the final segmentation is employed. In the final segmentation, the obtained image pixels regions were correlated, and in 3 channels the clustering regions were identified. After the identification of the regions were superimposed to the corresponding color channels in the images. This superimposition of the corresponding color channels will increase the particular ranges of intensities in the images, which shows the different intensity regions in the images more clearly. After the segmentation, the final performances of the processes were measured in terms of the calculation of PSNR and the MSE value calculation. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface for the execution of the process. So select any one of the input image which is present in the dataset. After that, we apply pre-processing. Then we separate the color channels, and the color channels informations were got. Then k-medoid segmentation is applied to the input images in patch ranges obtained. So this is the segmented regions for each of the patch regions obtained. So after the completion of this process, the segmentation of the detected regions were employed. So after the segmentation of the k-medoid, the original segmentation image pixels were obtained. So the segmentation is applied in patch-wise manner. So the final segmentation is applied. So this final segmentation is combination of the obtained regions and the selection of each different clusters in the images. So the final segmentation processes is obtained by the combination of these regions in the images. So as we can see, this is the segmented regions, and this is the clustering regions of the 3 channels that we have obtained. After the application of this clustering regions to the original images, this final segmentation is employed. Finally, the performance of the process is measured in terms of the calculation of PSNR and RMSE values. Thus, we have segmented the input images based on k-medoid segmentation methodologies. This processes will be useful in the segmentation of images in an efficient manner. Thank you.